video is for Stat 310 Handout 8 and will cover pages 1 through 7. Alright, let's go ahead and get started. To access the handout, you can simply go to the course website and select the link for the appropriate handout. This actually takes you to a Google folder that contains the handout, a PDF of the handout, and also the data sets that will be used for each handout. So clicking on Handout 8 Part A will bring that up. Okay, so Handout 8 is about comparing means across treatments, also known as one-way ANOVA. So we have an experiment here that was conducted to investigate the effect of sleep deprivation on hand steadiness. We had a total of 32 subjects across 4 different treatment levels. So these individuals were randomly assigned to a sleep deprivation level 12, 18, 24, or 30. There was a total of 8 subjects were assigned in each sleep deprivation level. Now the data that was obtained is just these individuals were asked to hold this stylus inside one of these holes, and what was measured is how many times they touched the edge of the hole. So that's known as the number of touches here. The data with the corresponding box plot, or side-by-side dot chart, is provided here. We've got 12 hours, 18 hours, 24, and 30. And then the number of touches across the 8 people. In the graphic here, we can see that the grand average, the overall average, is a little bit above 4. And then the green lines just indicate each average for each group. So let me go over into Jump quick and show you how to obtain this graphic. So here's what the data looks like inside of Jump. Every single person has their own row. So this is person number 1 here. 12 hours was their sleep deprivation level. This is replicate 1, and the number of touches this individual had was 4. All the way down, there's a total of 32 rows in this table. All right, to create the graphic, we're going to go Analyze, Fit Y by X. We're going to put the treatment or the factor in the X box here. And then the response variable or the outcome variable, which is number of touches here, is going to go in the response box. Go ahead and click OK. We can see that we get that kind of standard graph. To get the green mean lines in there, we're simply going to select Display Options and Mean Lines from the red drop-down menu. And then the other thing that I've done in that plot is Display Options Jittered Points, and that's going to just shake the points a little bit so I can see all of the observations here. So that's how that side-by-side dot chart is obtained inside of Jump. All right, let's move on talking about the model here. So this is going to be a one-way ANOVA model. It's actually called a treatment effects model. And the reason we call it an effects model is because we're going to be estimating effects for the various levels of sleep deprivation. So from the model here, we can see that we have, try that again. From the model here, you can see that we have an overall effect. And then the alpha I is just going to indicate the effect for each of the different treatments or treatment levels. So I is going to go from 1. 1 is going to indicate 12 hours. Then 2, 3, and 4, with 4 indicating the 30-hour sleep deprivation level. The J's in this are just indicating the different observations within each treatment level. So J is going to represent the replicates here. Okay. And J is going to go from 1 to 8 in this example. So again, mu is the overall response, average response. The alphas are just indicating the effect due to each sleep deprivation level. And then the epsilon terms here as we've talked before, are just the residual values for each observation. All right, let's just take a look at this big table here for a little bit to just explain the different parts of the model. So here I have I is level 1, so that's going to be for 12 hours. Level 2 is 18 hours, all the way down to level 4 is for the 30 hours. Y11 again is just going to represent the first observation. Okay, so J is equal to 1 here from the first group. So I is equal to 1. So I is equal to 1 and J is equal to 1 here. So this 4 is simply the first observation from that group. We go back up and look at that data table. 4 is just the first observation from that group. 3 would be the third observation from that group. So that would be designated by Y13. The overall average here for those data points is 3. Likewise for the other groups. We can see that when the sleep deprivation level gets up to 30 hours, the number of touches increases quite a bit. More than doubles from what we've seen at 12 hours. All right, let's talk about the statistical model elements now. So mu is the overall average. And if I'm estimating that from data, I will put a hat on that. So mu hat is just the 4.25. And that's going to be the average of all of the data points. In order to estimate what the mean is for group 1, I need to get from 4.25, which is the grand average, down to 3. So this alpha 1 is what we would call the effect due to 12 hours of sleep. It's going to be a negative 1.25. Again, the number of touches, we want that to be minimized. Hopefully we don't have any touches in this situation. So this alpha 1, simply if we go back and look at our chart, simply indicates how much we are decreasing here from the overall average. It looks like alpha 2 is going to be a little bit smaller because we're not decreasing as much. And then we can go over here to our fourth group. The alpha is going to be somewhat large over here because we are increasing quite a bit above that baseline or overall average. So we'd anticipate alpha 2, again, to be negative because that average is below the grand mean, but not as much. And that's a typo. That should be 0.75 there. I'll fix that on the handout. When we go to group 3, if we look at the plot up above, group 3's average is actually right on top of the grand average. So that estimated effect is 0. We don't have to move at all away from the grand average for 24 hours. And then as I said above, the estimated effect for group 4 is 2. It's going to be positive 2 here because I'm going above the grand average. 4.25 plus 2 gives me that 6.25. So this, in conjunction with the effect, will give me the average for that group. All right, a little bit on the residuals. So the residual term here, the last term, that is simply the data value. So the data value for my first observation in group 1 was 4. The mean was 3 there. So I simply take the data value minus the mean, and I end up getting a residual of plus 1 there. So that residual there for that first observation is plus 1. For the second observation, the actual number of touches was 6. If we use the mean as an estimate for that value or for that person, we'd have a residual value of 3 there. Likewise all the way down. Again, when we're determining the amount of error, we need to square these residuals and then add those all up. Okay? These residuals will actually balance each other out, and that's what we had talked about on Handout 7. All right, let's move back into JUMP now and show you how to get the output for that model. We're going to select Analyze Fit Model. We're going to put number of touches in the Y box. And in the Construct Model Effects box, we're going to put sleep deprivation level. So let's go over into JUMP and do that. So from the drop-down menu, I'm going to select Analyze Fit Model. Sleep deprivation is going to be a model effect. So there's that word effects again. Number of touches is going to be up here in the Y, or the response box. Go ahead and click Run, and that's going to provide a bunch of output for us that we will look at here. We will start with the analysis of variance part of that output. Okay, so we'll start our discussions talking. I did that again, didn't I? Let me try that again. Getting used to the zoom feature here. Sorry about that. How about I skip the highlighting of that? So we'll start with the analysis variance part of that output here. So let's move over back into our handout and talk about that. So the p-value is the thing that I care about here in the lower right-hand corner, and that p-value is 0.0008. The research question that p-value is answering is there a statistically significant effect due to sleep deprivation? And we're analyzing the average number of touches. So the testable hypothesis here, the null hypothesis, is that there's no effect. And then the alternative hypothesis is that there's an effect of some type. So what's the decision from this test? The decision from this test is just to check whether or not this is less than 0.05, which it is here. So the value 0.008 is indeed less than 0.05. So that is true. So that means I do have enough evidence to support the research question. So again, highlight that, bold that, or whatever. I do have enough evidence to support the research question. Write in an appropriate conclusion in layman's terms. Again, we are going to just state we have enough statistical evidence to say, and then we can just grab the research question. So we have enough statistical evidence to say there is a statistically significant effect. Maybe we can clean that up a little bit. We have enough evidence to say there is an effect due to sleep deprivation on the average number of touches. And the p-value for that statement is 0.0008. Okay, so that answers that initial research question. Next, we're going to talk about investigating those effects. So let's talk a little bit about those effects. In order to get each of the estimated effects, inside of JUMP, I need to select Expanded Estimates from the red drop-down menu. So I need to go up to the red drop-down menu, select Estimates, and then Expanded Estimates. And then these will be returned here. So let's go do that real quick. If we don't do the expanded estimates, what we're going to end up doing is just getting 3 of the estimates here, 12, 18, and 24. So we're missing that last level, or that 30 hours. So I'll talk more about that at the very end. If I want the expanded estimates, those will give me all of those. So I can, again, select that from JUMP here. So the expanded estimates has, indeed, all 4 of those levels for me. All right, so let's talk a little bit about what those mean. So the sleep deprivation for 12 hours, that effect is negative 1.25. So in other words, all that's telling me is that for that average, I'm dropping down 1.25 from the overall average. Now, with a different sample or a different study, these averages are going to change. All right, so there's certainly random variation that exists with each one of these averages. And for that matter, with the overall average as well. What I'd like to know, or what this test is going to do, the one we're going to talk about here, is whether or not 12 hours has some effect, okay, or does the 12-hour average stay away from the overall average? Equivalently, we're saying, does 12 hours have some effect? If that's true, then the alpha 1 term, okay, the alpha 1 term is going to be different than 0. The test for that is right here. So the test A, this p-value right here, is just testing whether or not the alpha term is away from 0. The p-value for that, if we just fill one of these in here, is 0.00099, excuse me. Is that less than 0.05? It is. So is it different from the average? And that implies that that effect is indeed a significant effect. And what we mean by significant effect, again, is that that average for that group differs from the overall average. Let's look at the next one down. So this is going to be sleep deprivation for 18 hours. The estimated effect is negative 0.75, which again just tells me how far down I go from the overall. The p-value for that one is 1082, 0.1082, excuse me. Okay. Is that different than the average? Or can I say statistically that that effect is different than the average? I cannot. Okay, so here the p-value, the reason I'm saying this is p-value not less than 0.05. So in other words, there's not a significant effect, okay, for sleep deprivation 18 hours. In other words, that's too close to typical or too close to average there. The alpha 3 is going to be right on top of the grand mean, so there's obviously no effect there. And then finally, D is going to have an effect because that's a value of 2 there, so that's significant. Okay, the p-value there is 0.0001. So yes, that's a big effect there. So certainly when we get up to 30 hours of sleep deprivation, we can see that the number of touches significantly increases above the overall average. All right, let's talk about the 95% confidence intervals for these effects. So there we were doing the testing for those effects. If you want to get the confidence intervals for those, again, from my red drop-down menu up at the top, I need to select regression reports and then show all confidence intervals. We go back down to our expanded estimates, and those confidence intervals are provided. Let's talk a little bit about how those are obtained. So I have the estimate here, and I have the standard error for that estimate. So here you can see that it's negative 1.25. The standard error is 0.45. And the confidence intervals are over here for that. So I need to take the estimate, which is negative 1.25. For the lower end point of my confidence interval, I subtract. This value here comes from the t-table. The t-table with, in particular, 28 degrees of freedom. So I'm going to use degrees of freedom equal 28 here for the error term, excuse me. I'm going to use the degrees of freedom for the error term for that t statistic. You can grab that off of any online statistics calculator here. I've provided one here. Degrees of freedom 28, confidence level is 95%. The t-value is 2.048. And then I just multiply that t-value by my standard error. Do those calculations and I can get my lower confidence interval or lower confidence limit. For the upper confidence limit, I would just change that negative to a positive here instead. So I'm just going up instead of down. Now, this confidence interval does not include 0. So 0 is over here somewhere. Okay, so that means we definitely have a negative effect at sleep deprivation level 12. Let's go ahead and just bring up our interpretation here. Okay, so we definitely know there's a reduction in the number of touches for sleep deprivation level 12. Interpretation is provided here. We are 95% certain that the true effect for sleeping 12 hours is a reduction between 2.18 and 0.32 on the average number of touches. All right, real quickly, just want to show you why the expanded estimates are not the default inside of JUMP, or for that matter, any software package. So the expanded estimates are not shown by default because the last effect is not really estimated. And we can compute that last effect by considering just the other effects that we have. So here are the algebra steps when I have 4 levels from a balanced design with 8 replicates in each level. The overall average is simply add up all of the data points from group 1, group 2, group 3, group 4, and then just divide by the total number of observations. That is equivalent to just taking 8 and multiplying by mean 1, mean 2, mean 3, and mean 4, and dividing by 32 there. That's the total number of observations. We can do a little bit of algebra there, and we get down to the following. I have 4 mu hat on the left side, and I have 4 mu hat on the right side, plus all these others. Well, if this is equal to one another, then all of these must sum up to be 0. And what we call that is the sum to 0 constraint. If we do just a little bit more algebra with that, we can determine that the last effect is just the negative of the sum of the other effects. So this is true anytime we estimate our effects using this treatment model. You can see here if I add up negative 1.25, negative 0.75 plus 0, I'm going to end up with negative 2. So end up with negative 2. So the sleep deprivation effect is going to be the opposite of negative 2, which is simply 2 there. So when our software displays the estimated, when software displays the estimates, it does not display this last one. So you have to go under expanded estimates inside of JUMP in order to get those displayed. All right, that does it for Handout 8, Part A for Stat 310. Thank you.